Third class Meyers, the topic I'm going to be covering is general specifications of the Naval Combatant Ships and essentially the different types and what they do. There's two different types of aircraft carriers. The CTOL, or conventional takeoff and landing aircraft carriers, which usually need catapults, and then there's the STOVL with a short takeoff and vertical landings, which use basically like a ski jump for a greater lift. Another example of the naval combatant ships, or a type of naval combatant ships, would be the cruisers. They're enormous. They have a displacement of more than 10,000 tons and are sufficiently armed to operate on their own. Just as the cruisers are armed to operate completely on their own, the destroyers are as well. They're a little bit smaller than the cruiser, but they are multifunctional and designed to fight submarines as well as other surface vessels. Frigates are very versatile warships. They're suitable for air defense, anti-submarine, communication. Corvettes are on the smaller side of the warships, and they have a displacement of 700 to 2,000 tons and are generally very well armed. There's also the fast attack craft, or the FAC. They're even smaller than the corvettes and have a displacement of less than 70 tons, a speed of around 25 knots, and are designed for fast hit-and-run tactics with a range of just 100 miles off the coast. A few different types of submarines would include ballistic missile nuclear, nuclear-powered attack submarines, underwater-to-surface missiles, cruise missiles against land-based targets, and general-purpose diesel-electric submarines. There's the mine countermeasure vessels, or MCMV. They're mainly used to defend against mines that may be put out to destroy a fleet. There's also amphibious ships, which are designed to launch amphibious force to a coastal operation area. So they'll go straight up to the land, and they can operate both in the water and on land. Landing craft are similar to amphibious ships, but instead of being multi-purpose completely, they're meant to just take people from the water onto the beach. As far as existing trade patterns and commercial applications go, while the naval combatant ships aren't directly involved in trading, while they are not actually pulling into port and trading items, they're a major component of making sure the ports are safe and that trading is allowed to go on. Flags are normally associated with vessel types. Obviously the country's flag, the service flag associated with the vessel, so if it were the German Navy, they'd be flying the German Navy flag. If it were, the Japanese Coast Guard, they'd be flying the Japanese Coast Guard flag. And then, of course, the general nautical flags, which you could find on any ship. Vessel construction, there's a few very large areas where many of the vessels are built, especially for the United States. Smaller parts can be built and then shipped to these larger areas to form the entire thing. So it's not really one place building the entire thing. In a lot of cases, it's a large collaborative project that involves multiple people working on one common goal. I wouldn't say all the subs, but a large portion of them are actually built here up in Groton or at the dry dock company. As far as propulsion systems go, they're incredibly varied, and depending on the ship, they can be anywhere from a few MGTs and MDEs, or main gas turbines and main diesel engines, to nuclear reactors on subs and aircraft carriers. As far as stability and structure concerns go, some of the strongest ships in the entire world are naval combatant ships. Some special or unique auxiliary systems that naval combatant ships would have would be not necessarily the fact that they have sonar, but the advanced sonar that they have is far beyond anything in the private sector. When it comes to weaponry, there's nothing above naval combatant ships, and that just makes sense. Some of the damage control systems are incredibly advanced and well prepared to fight any sort of casualties. And the last one might be hull maintenance systems. So instead of pulling into a port and having to check the hull all the time, they could install one of these hull maintenance systems which would keep track of the condition of the hull and actually repair it while they're still in the water.
Hello, I'm Eric Polarski. I'm a third-class cadet at the Coast Guard Academy, and I'm talking about some of the regulations, either safety and environmental, that apply to Navy combatant ships. One of the surprising things I learned in my research was that Navy ships and other naval combatant vessels are subject to the same rules and regulations as almost every single other civilian vessel, with a few minor exceptions. Naval vessels have to follow conventions such as the safety of life at sea, or SOLAS. They also follow a lot of the marine pollution regulations such as MARPOL. There's also, the big thing is they have to follow the rules of the road, just like any other vessel that the Coast Guard publishes. One of the few minor things that we learned is that the only areas where they really have some leeway is that they can change some of their signal lights. There's some day shapes and whistles, as long as their modified ones don't share the same shapes or light configurations but different meanings as any other signals inside the rules of the road, and that's for both international and inland regulations. One of the specific regulations that pretty much only has something to do with naval vessels is for a vessel engaged in mine clearing operations, which is 3 black balls shaped in a triangle, such as one here, here, and here, and 3 green lights in the same sort of configuration. Another area of regulations that apply to naval vessels is that they actually have additional regulations. One of the big things, and it's outlined in the Deck Watch Officer's Handbook, is a lot of the naval regulations that they're subject onto, such as the naval regulations and also the Operational Navy Instructions 3120.32, which outlines a lot of the instructions, the organization of how vessels are supposed to be run, what components are on board. One of the largest concerns with naval vessels is some of the environmental impacts and pollution. Like I stated before, they also have to follow a lot of the marine pollution laws, but a bit more so because a lot of the products, chemicals, that sort of thing that are on board naval vessels is a lot more corrosive and dangerous than what would be on civilian vessels, such as large amounts of combustible fluids, flammable liquids, gunpowder, that sort of thing, stuff that is easily explodable. And that has an entire area of regulations, both international and country-specific, that have to do with the maintenance, security, and upkeep of those hazardous materials.
I'm Colin Edwards, and my section is about new technology that the Navy is researching. The Navy is on the forefront of advancing ship technologies. Many of what they're researching now is still classified, but what they're making available to the public now is much more advanced than a lot of what the civilian market's looking into right now, because the Navy needs a wide variety of requirements that the civilian market doesn't necessarily need. One new ship that the Navy is looking into is the Littoral Combat Ship, or the LCS. It's the Navy's requirement for a shallow draft vessel to operate in coastal waters. The General Dynamics is in charge of making it, and they went with a trimaran design, so it has 3 hulls. This design provides greater stability and provides a lower total draft. This allows it to better operate in coastal waters and allows for better stability, which also helps with facilitating the launch and recovery of aircraft and other vessels, as well as firing. Another vessel, although a little bit older, is the Sea Shadow. It was built in 1985 by Lockheed Martin. It is designed to test stealth technology for other U.S. Navy vessels. It is still officially the only unclassified vessel to be designed to be completely invisible. Even the stealth ships they have nowadays are not designed to be totally invisible, but to have a minimal radar cross-section. The vessel uses a catamaran design, which does limit the amount of space in the interior, but it also limits the vessel's radar signature. It's also very low to the water, which helps it to, that combined with the flat black paint makes it very hard to detect, especially at night, where it's almost invisible, even from the naked eye. And again, the ship is covered in radar absorbing material, which helps to, again, limit the vessel's radar signature. The Navy is also looking to advance its propulsion systems. A lot of the Navy currently, especially the submarines and aircraft carriers, are nuclear powered. Nuclear power plants are being made more efficient and smaller. This will help to, especially as we move into the next generation of submarines and aircraft carriers, to help allow for more efficient, better propulsion systems, giving more space to other onboard systems. Many of the Navy's new vessels that aren't going to be nuclear powered, they're looking to do a gas turbine and diesel hybrid system, where they have both on board. The Navy's integrated power system, it's a new system the Navy's developing. It is where a single engine is able to drive both electric motors that run the propellers and the diesel generators. This helps to allow for more space in the engine rooms, as you don't have multiple engines doing different tasks. You have one engine running both the motor and the generators. The Navy is looking into fuel cell technology, which will help it to run both economically and ecologically more efficiently. And also looking into high-speed generators, which will help produce energy more effectively. There's also the Zumwalt class destroyer. It's a new destroyer that the Navy is looking into buying. It's designed with a tumble-home hull. That is, the hull at the bow slopes inwards from the waterline rather than outwards as in traditional vessels. This reduces the rare signature of the vessel and eliminates some wave resistance, allowing it to move more efficiently through the water. It's going to use the integrated propulsion system as a drivetrain or a drive system using gas turbine engines. This eliminates the room required for engine equipment and propulsion systems such as drive systems and reduction gears, that kind of thing, and allows for more power to the ship's other systems such as the guns and fire control technology. And it also minimizes the noise signature of the ship. The Navy's been doing a lot of research into their submarine technology. The Navy's been developing a new material that will help prevent submarines being detected. It's a coating that goes on the exterior of the hull, of the submarine. The coating will eliminate sonar detection by eliminating radiated sound from the engine and things inside the submarine, and absorbing incoming radar waves, kind of like radar absorbing material works for surface vessels. This new system, although effective, is technologically a few years away and will ultimately prove to be very heavy on the submarines, so it's going to come at a cost of most likely having to limit other things carried on board the submarines.
My name is Darian Durier, third class. The next thing I want to talk about is actually collisions with U.S. and other naval combatant ships across the world. One that I found that I want to talk about is the USS Porter, which was a Navy ship that crashed with an oil tanker Aswan, near the Strait of Hormuz. The collision caused $2.3 million in damage to the structure of the ship, and a good amount of oil and other fluids were leaked into the ocean. Also, the USS Hartford, which is a nuclear-powered sub based here out of Groton, Connecticut, collided in the strait with the USS New Orleans, which was a San Diego-based amphibious sub. USS Hartford sustained $102.6 million worth of damage. Naval combatant ships have encountered many different casualties and many different events that have led to a safer naval combatant ship and to a better ship that is able to fight the missions that are out there today all across the world and better protect itself from people trying to attack the ships. One other case was actually out in the Pacific during a refueling, refueling, where a 844-foot long U.S. Navy vessel collided with a refueling tanker in the Pacific Ocean, causing damage to both ships. But apparently there were no fuel spills out in the middle of the ocean. Outshore or out at sea, refuels or replenishes are very dangerous due to the different forces acting on the ship. Slight changes in heading or speed can be catastrophic for both ships. And in this case, we saw that this was a pretty significant casualty to two U.S. Navy combatant ships. As a result of this, we were learning better ways to conduct these operations and other operations that naval combatant ships do every day out at sea.